In this video, we're exploring the closure property in binary operations. A set is said to be closed under a binary operation if any two elements from the set always combine to produce an element in the same set. For example, if we take any two real numbers such as 4 and 5 and add them, the result will always be a real number. Hence, real numbers are closed under addition. It's the same for multiplication and subtraction. If we take any two real numbers, such as 4 and 5, and multiply them, or subtract them, the result will always be a real number, regardless of the order that the numbers are in. However, real numbers are not closed under division because dividing by 0 gives an undefined result. Now let's test closure with a custom operation. Suppose the set S contains 3, 4, and 5, and the operation star is defined as 2a plus b. Is the set closed under star? To answer this question, we can build the operation table using the three elements in the set. 3 star 3 is 9. 3 star 4 is 10. And 3 star 5 is 11. Pause the video and complete the table. Notice that the results are not in the set S. That means S is not closed under this operation. And remember, finding just one result outside the set is enough to say closure does not hold. Let's check another set V that has only two elements, 0 and 2, with the operation x times y over 2. Again, we can do an operation table. 0 star 0 is 0. 0 star 2 is 0. 2 star 2 is 2. Notice the results are always 0 or 2. That means every result is a value that is in the set V. Hence, the set V is closed under the operation star. So in summary, closure means the results of your operation always stay inside the set. If all results are in the set is closed. If even one result is out, the set is not closed. This is the end of our series on binary operations and their properties. Thanks for watching. Remember to like, share, and subscribe. See you soon.